So, yeah, right. Welcome to Kodsnack. I'm Fredrik as usual, and today I'm here with Emil and Leo. Hi, Leo.
Hi, Fredrik.
And hi, Emil.
Hey.
So Emil is a semi-regular here with his third appearance, but this is your first time, Leo. So, I mean, very shortly, who are you? What do you do?
Well, first of all, thank you for having me. Very, very nice also, Emil, for inviting me here. I think it'll be a lot of fun to talk about Riot and stuff like that. Yeah. My name is Leandro. I'm an Argentinian engineer. I have been living out of Argentina for, 12 years so far. And the last 8, 9 have been here in Sweden, actually.
Ooh.
So, jag är svensk nu. Jag kan prata lite svenska också. Men not so much so that I would do technical conversations that. I have a background in building stuff. I am not formally trained. I have a high school diploma. That's my highest achievement academically. But I've been building things for startups for a long time now. I think I've been making a living off software for almost 15 years now. Just a long time.
Yeah.
I started pretty early. And I've been through many stacks, right? Like I've worked through, the usual C and C++, trying to make games, PHP, Python, and Django. I've done like Ruby, and I've done Rails and Sinatra and stuff like that there. I've been through the whole move between like Backbone.js to Ember.js to Angular.js to React.js eventually. And I kind of landed at some point working on larger systems in Erlang because I really wanted to build systems that were like, okay, few people can have a massive impact. Impact has been an important thing for me, especially because of the work at startups. If you don't figure out what the right thing to build is, you're going to be out of business. And that means there's not going to be anything to eat. And that sucks. So, that's a little bit about me. I came here to Sweden to work for Klarna, and then I worked for Spotify as well. So I also got to do Java there. But I don't talk about that much. And lately, I've been working with other different startups in different spaces. And today, I am leading the build system team at Privér, which is an OCaml company that they work on the OCaml ecosystem a lot. That's a little bit about me.
Wow. Lots of interesting stuff there already. So we thought we were going to try and focus on the on the OCaml side of things today, right?
Might as well. I think it's a good topic to tackle.
Yeah, and I think the average listener has probably heard of OCaml, but maybe not much more than that. We know it's a language out there.
Yeah, that's accurate. It's a language out there. So OCaml comes from a very long lineage of thinking about programming languages and thinking about safety. So, programs have bugs, and they've had bugs since they were created, right?
Yeah.
And around somewhere in the 70s, this guy, Robin Milner, right, was thinking, how could we make programs that never fail? And, I'm paraphrasing here. This is not exactly the way that he thought about it. But he designed this language called ML, meta language, right? As an assistant from a different system that was like more even into the proof part of programming, which we don't really talk about, right? Most people just talk about programs, no proofs, right? And ML was an interesting language because it had a small type system that was very expressive. And over the years, that language has been evolving. It actually is not used like that that much at all, right? But it has established a lineage of languages from which you have like standard ML, and you have CAML, and you have OCaml, and you have F#, and it's also influenced languages like Haskell and so on. And OCaml is just one of those in that lineage. So today you could say like F# and OCaml, they're kind of cousins. They come from like the same tree, right? And they're functional programming languages that are very pragmatic. So they often have imperative or even object-oriented features, right? Which are not very common in other FP languages. They're also not pure. They're essentially allowing you to do side effects anywhere, which for some people is like blasphemy. How could you do that, right? But for me particularly, coming from like the Erlang side of functional programming where everything is impure, I'm like, I am happy that I can just print something without having to do an IO monad.
It saves some time sometimes.
It does. It definitely does, especially for onboarding people. It's like you can write OCaml the way you write C, right? For the most part. And that means an imperative programmer or a procedural programmer can just start writing it and then slowly over time, right, make things more and more functional. And Haskellers also are welcome to join OCaml and use OCaml, but they might have to give up some things, which I think will like leave some of that amazing brain power they have for working with types to actually ship products. You know what I mean? A little friendly stuff there for our Haskell siblings.
So Haskell people, they will feel reasonably at home in OCaml, apart from having to let go of some strictness in some places.
I guess the language isn't that pure that they might want to.
No.
But
it's a different thing.
If they loosen up a little bit, they could probably like it a lot, because it is like a really nice language. I come from like the Rust background. I've been working with Rust, like doing. Even if I go back and look at some projects that are not that memory efficient, I know how to write, efficient Rust. And OCaml is like in a way like the functional version of Rust. There's a lot of similarity in the language, like for instance, like types, and you have options and result that you can work with almost the same way in both languages. So if the Haskell developer loses up a little bit, then you could go.
Yeah.
So if I'm a like modern in quotation marks, like full stack front end developer who comes from, started with JavaScript and have gone towards typing and TypeScript and perhaps, started to pick up that functional stuff is nice. Would I feel completely lost in OCaml, or would I feel like, oh, this is like a pure version of what I'm looking for?
My first gut reaction is probably yes, but we have done work to make it easier for you to do that. If you're like a TypeScripter that wants to write OCaml, we have two things that are super interesting. Most ecosystems that have a programming language, they have that. They just have the language. They may have an alternative like flag or something to output some sort of JavaScript. In OCaml, we have the big benefit of having a very hackable compiler, right? And that means the compiler is kind of like pieces that you can take apart and replace, right? Ooh. So people have replaced the front end of the compiler, we call it, right? So you get a new syntax. You can write seemingly a new language, right? And still have it be OCaml. And people at Facebook built at some point Reason, which was actually created by Jordan Walk, which is the creator of React, who prototyped React in standard ML. So there is like a big connection, if you like React, to OCaml and standard ML and all these things, right? And that syntax, it looks like OCaml with semicolons, so it kind of looks more like JavaScript. So when you look at it, coming from TypeScript, you don't go like, what's all this stuff? It's somewhere, this seems familiar. I can read some of that code. It even has support for like JSX syntax, right? Ooh. So you can do React with that, right? But that is only what you type.
Yeah.
The second part is how you run it. Because OCaml compiles to a couple of things. Most of them are native targets, right? So you can compile native executables in many platforms. However, the backend being also replaceable means that people have written new backends for OCaml, right?
Of course.
And we have one backend called Melange. And Melange is amazing. And it outputs JavaScript. So you can write Reason, right? And have it spit out JavaScript. So you literally could just say, hey, I am writing this JavaScript, right? And people will never know you're writing Reason or OCaml and so on. And it works brilliantly, to be honest. It works really well. Yeah, a large part of messenger.com at Facebook was rewriting on Reason and is using a version of the Melange compiler. So it's something that is definitely being put out there to test. Like, this is not a toy project. Like, this is like serious business.
So I want I started to build like a project called OCaml by example, and I'm using Melange for this particular project. And like I've been writing a lot of TypeScript, and it wasn't like new stuff when I started to work Melange. I understood almost everything. There was some tiny stuff, like for instance, when you want to log something, you do console.log in JavaScript, and within Melange it was more like js.log and something else. So it's like you need to rethink a little bit, but most of the stuff is like if you are a JavaScript developer and we're working a lot with JSX, then this stuff isn't that new. Melange is a little bit more strict. So for instance, like use effect is called use effect 0, 1, 2, 3, 4, 5, and the number represents how many depths you can add to the use effect.
Yeah.
So it's more those kind of stuff.
Those API differences are interesting. because OCaml is a very small language. JavaScript and TypeScript are kind of large, especially TypeScript has a massive type system. The things people do in TypeScript is just like, why would you do that?
There's so much of it.
You didn't have it. There's so much of it. But OCaml has like a core, right, language that is essentially the same language that, you know, we had in the 70s. So it hasn't changed much.
Yeah.
And it's something that's really small and you can learn in a couple of days and you can master in a couple of weeks, right? And of course, you can get better and better and better at using those little shapes and pieces. The language has more extensions. It has a lot of different extensions, but most of those are not going to be used like for 90% of the work, right? So you can get real productive real quick as long as you're comfortable working with those constraints, right? Some people don't like working with those constraints and they work better with dynamic languages, and that's completely fine, right?
Yeah.
But for people like us that maybe we like functional programming and types, it's like, yes, constraints, you know, I am limited. That sounds awesome.
Yeah, the right constraints in the right places.
Exactly.
It
Yes.
can be magical. Yeah. So how large or small is like OCaml in community-wise and stuff like that?
I think it's really hard to compare OCaml to JavaScript. Like JavaScript is huge, but like the functional aspect of programming in general is a bit more tinier than the rest. Mainly as I think, in my opinion, like functional programming have this doom of being complicated to work with, and it's not specifically like the language itself. It's more the people working with the languages making everything so hard. Like they need, instead of like releasing a 001, they want to release a version 1 that has everything, and like need to like think of everything before they release it.
Okay.
And there's those kind of stuff that I think make functional programming in general like a bit tinier community. But thank you to like, so currently on Twitter we are sharing the word of OCaml, like spreading, and I think that it's more and more people are talking about it. So I think the community is growing like, you know, tiny pieces. And if we in a good way could remove that doom of being hard to work with, I think it's called academic view kind of thing on functional, then I think we could grow it even more.
Yeah. So just to add a couple of points there, what Privér was saying is definitely right. OCaml is a much smaller community. It is not so small that you will feel alone, though. It has users, industrial and academic users, a lot of academic users, because it's being taught as a language in many universities, right? The compiler itself is primarily owned and developed by a university in Riot in France. So there is a very different situation from, for example, the Go team, right? Building the Go programming language and so on, or the Elixir team that primarily builds Elixir from Dashbit.
Yeah.
But, you know, functional programming in general is much smaller, as Privér said. Some languages are really pushing that boundary. Like when you look at the Slack of Erlang, for example, it has maybe like 4,000 people. And that's like, you could probably count that as the real number of Erlang programmers worldwide, right? Yeah. It's like there's 4,000 of them.
Yeah.
Which is not that much. It's like 10 per country or something like that. Maybe 20. But if you look at Elixir, Elixir has done wonders in community growth, right? By focusing on developer experience, in usability, right? Focusing on giving you higher level abstractions. And that reflects in how big the community is. Yeah. The conferences they run, there's at least 2 conferences a year on Elixir, right? And they have hundreds, if not thousands of people going there, right? The Slack is at least 40,000, so maybe one, potentially close to 100K maybe at some point. So closer to 2x bigger than Erlang, right? Yeah. And OCaml has started very small, and it's for a long time being used very privately. Like people didn't want to do a lot of sharing. I don't know why. Because Erlang has the same problem, right? Like people just use it as their secret weapon. I guess I understand why. Sure. And through things like Reason, there's been influxes of people into the community, right? There's a whole separate Reason Discord from the OCaml Discord, right? And that one has been so much more active during the Reason days, right? That has revitalized OCaml, right? More recently, the new Rescript language, which was also based on OCaml, right, is driving a lot of interest into OCaml, because if you want to contribute to Rescript, you have to learn OCaml as well, right? So in that sense, there's been this like arrow pointing towards growth, towards a more inclusive community, a community that's maybe more interested in the actual industrial aspects of the building of, right? Which is not better. It's just better for the people that like that, right? Because if you're a PhD student, OCaml is perfect for you, right? But if you want to build your own tiny SaaS with that, maybe it's not quite there. Like there's still some missing pieces and so on.
Yeah, so it started from the academic side and it's sort of moving wider and wider gradually by the sound of it.
Yes. But there are large companies using OCaml and have been using OCaml for some time now, not just a couple of years, a couple of decades, right?
Yeah. Oh, yeah.
Yeah, I think Meta is one of like the biggest companies that uses OCaml.
Yeah, Meta is a big one.
Yeah, every time I go on like GitHub search and like try to find pieces of OCaml code and use like the lang OCaml, I always find like result from Meta.
Yeah. Most of Meta's developer tools are written in OCaml.
Wow.
But of course, we cannot go to a podcast to talk about OCaml without mentioning Jane Street. And Jane Street is that one company that it's a high frequency trading firm. And they build everything in OCaml, right? CLI tools, servers, the trading code, right? All the logic for doing that. They build the machine learning stacks on that. They build a build system in OCaml that they use to build their OCaml. Literally, it's like, we're going to build OCaml to build the OCaml that we write. It's like very meta.
Wow. So are they like driving things as well, or are they just like the famous example people want to?
And they do a lot of driving. They're doing a lot of contribution to the ecosystem. For example, they own the core of the Dune build system, the engine. Is something they work a lot on. They're also funneling resources as well by funding all the companies working in community projects, right? And I'd say that they're pretty involved with the community.
Yeah, sounds like it.
I actually, like, me and Leo had lunch like the other day, and I asked Leo like, hey, I've seen this Jane Street thing. What is it? And Leo was like, yeah, imagine that everything, like every piece of code that's written in a company is written in OCaml. And I was like, oh, so that's the Jane Street way, like everything in OCaml. He was like, yeah. Yeah.
Very simple and straightforward.
Yeah, so like if you search for OCaml, you probably find Jane Street somewhere. Everywhere.
Oh, they have. I don't want to say a number, but maybe like 20% of the packages in the OCaml repository are Jane Streets.
Wow.
Probably more.
Yeah. Sounds like they're doing it in a good way, though.
And something we are doing also to like improve the general OCaml community is working on a lot of libraries. And I actually like back in November, like 2023, I was in a position where I want to learn something new, and I was looking for a functional programming language. I want to learn something. So I found OCaml by Twitter, like people talking on it, and then I found Riot, which Leo have been working a lot with. And I think like when the first time, like when I started work on OCaml, like doing the advent of code stuff, I actually didn't like OCaml. I liked it like a little bit more every time I worked with it, but I needed like a real product. So I found, as I said, like Riot, and that was like the piece I needed to like, ooh, this is nice.
Cool.
That makes me happy to hear, man.
Yeah. So what is Riot?
Ooh. All right. So Riot is an experiment in bringing all of the things that are good about Erlang and the Erlang ecosystem and the Elixir ecosystem into OCaml. So how we talked about how OCaml had started with this ML family of languages that were like, can we make programs that don't crash, right?
Yeah.
The Erlang way of thinking is super different, right? And it was primarily developed under like strict market and product constraints. And they take the approach of saying programs will crash.
Yeah. Exactly.
So, let them and deal with it, right? Like embrace that failure in some way. So it's a very different school of reliability. And they're both excellent, right? And they're actually compatible. You can build software that plays to both, teams of that split. And I think that will be perhaps the best place to get reliability from, because you get reliability from, this never crashes, but when it does, because it will, then you also have this approach.
Yeah.
And the way that Erlang does this is by building this idea of supervision trees.
Yep.
Where a program in Erlang is composed of tiny, thousands, if not millions, of tiny little processes, which are not operating system processes. They're tiny units of computation within the Erlang program, right? Super cheap to use, and they communicate via message passing. And they can be monitored. So one process can actually be looking at other process and know, that process crashed, right? So the Erlang motto of let it crash comes from the ability to say, I will have another process, right, looking at you. So when you crash, that process will restart you, right?
Yeah.
And start from a known state.
Yeah.
Which is a fabulous way of building reliable systems, right? Because it is virtually impossible to kill an Erlang system.
Yeah.
And I adore that. I love that. I think it's fantastic. It's like a living organism in some sense. It's like it's struggling to live, and it just wants to stay alive. So having a background in Erlang, I've been struggling with scaling code bases in Erlang, right? If you keep grabbing code, then you need more and more and more tests. You need to program more and more defensively and just like assert many places. And even then, at some point, you make a change and like you have to wait a long time for all your tests to run to make sure that you haven't broken anything. Collaboration can be tricky as well because you don't have a lot of static guarantees, right? And that kind of means that scaling Erlang is hard. It's expensive as well, which is one of the reasons I think a lot of the people that work in Erlang work in rather small teams, right? Infamously, the WhatsApp story of like 10 engineers, working in the code base, serving billions of messages a day. Yeah, that sort of thing. So at some point, I started writing this thing called OCaml, which was trying to bring in some of the safety from OCaml into Erlang, right?
Right.
And I went through a phase there trying to type Erlang, trying to understand what is the subset of the language that can't be typed, because the language is quite dynamic in some ways. And I ended up realizing or learning that there is a subset of OCaml, which I call the core language there, right? That is actually Erlang, right? And vice versa. So there is a subset of both languages that is the same language. And I was like, holy crap. Like if you can do that, you can translate from one to the other. So we can get all of the type system of one, right? And just run it on the second one. And that was interesting. But OCaml didn't pan out because building a whole programming language is an entirely different thing, right? It's a big effort. It's not just the compiler. It's the communities, documentation, examples, libraries, the culture really around that. And if that's something that's interesting to you, I definitely think you should reach out to Louis Pilfold to talk about Gleam. If you haven't yet, because he actually has gone down that path, right? And has made that language. And that Gleam is brilliant. I love it. But yeah, so you can tell eventually OCaml shut down. And sometime later, I was like, well, if we cannot take OCaml onto the Erlang VM, could we take the Erlang VM into OCaml? Right?
Nice and simple. How hard can it be?
Just invert the arrow. What could happen, right? Like what could
really
be the worst thing here?
On the whiteboard.
Yeah, exactly. Very easy on the work. You just have like to draw the arrow on the other end, and that's it, right? You're good. But it took a little bit to be able to do that because for a long time OCaml was single-threaded, right? Which meant up until 4.14, so 2 years ago, OCaml was running on a single CPU, and that was it. If you wanted to have more CPUs, you had to spin up more programs and orchestrate the programs from the outside.
Yeah.
And that's okay. And a lot of people make that work very well, Jane Street, right? But I don't like working that way. I like to have my sort of program automatically be multi-core because that's what I got used to with Erlang and Elixir, right? So when OCaml 5 was released, they introduced two things. One, multi-core, which I was like super excited about. But the second feature that was fundamental for being able to build Riot was algebraic effects.
All right.
And we don't have to dig too much into that because that could be a podcast on its own, right?
That would be a link in the show notes.
Yeah, exactly. So algebraic effects, asterisk, right? But essentially what algebraic effects give you is a way of saying, I'm going to raise an exception, right? And then anyone that catches it can say, let's continue the work where the exception was raised, right? kind of like that. So I think that would be a good example because I think most people are somewhat familiar with exceptions, right? Obviously, they don't have to be exceptions, but that's the behavior they have.
Yeah.
And that means we get resumable continuations in OCaml, which are pretty much Erlang processes, right? And when I saw that, I was like, holy shit, this is it. This is the moment. We need to build it. So what is Riot? And probably you're going to cut this thing and put it at the beginning because I should have started there. Riot is an OCaml 5. It's a multi-core scheduler for OCaml 5 that lets you write programs in OCaml that are multi-core for free, where you orchestrate processes, OCaml processes, like tiny virtual like green threads, not OS processes. And you can have hundreds of thousands of those. They're really cheap. And have them communicate with each other via type-safe message passing. And that means we can write systems in OCaml that run like in Erlang.
Yeah.
That run across all of the cores, right? That have failure isolation for very small things or large things, that do supervision trees. So my hope is that we'll be able to write OCaml programs that run forever and self-heal in some way. So that's a little bit of what Riot is. Yeah. Sorry for the long story.
You get all the types that you want.
And you get all the types. Yeah, exactly.
And I used the Riot mainly within DBCaml to build a pool because that was the idea. Like DBCaml is the OCaml version of Rust Squelex, and Squelex is like a really nice SQL library. And every like connection within the DBCaml is essentially a process using Riot and supervisors, so on.
Yeah, and those lightweight processes are basically the continuations, which are the algebraic expressions enabled.
Yeah, exactly. Like when we don't use that much algebraic effects. We use them like in 2 or 3 very specific things. Like when you are inside a process and you call the receive function. If you don't have messages, you want to sort of suspend yourself and be like, I will wait for a message to arrive, right? And that's what happens. So receive is kind of like an exception that says like, give me a message, right?
Yeah.
And then the scheduler says, well, you don't have any message, so I'm just going to put you there on the sleep queue. When you get a message, we'll be waking you up.
We'll tell you.
Exactly, we'll tell you. Exactly, yeah.
And what's so good with like the whole Riot initiative is that mainly you, Leo, have been working on like a lot of more stuff than just Riot. Like you extend, like you're taking like pieces of the Riot code, correct me if I'm wrong, and make it libraries that other people can use in their programs and their applications. Like for instance, like Gluon or...
Oh yeah. I mean, we've had to build some things to make this run nicely. And essentially, we have built an entire stack from scratch. Like we have built conditional compilation for OCaml so that we can build some libraries on different operating systems, right? And use the right C code for the different operating systems. We have an async engine that we wrote for OCaml as well called Gluon. And I actually really like it because it has this very tiny usage of unsafe features, right? That make it super fast. But, some people are like, no, what you going to do this? I'm like, what's the alternative? The alternative is like 2 orders of magnitude slower performance. I'm okay with an object magic here. You know what I mean?
Yeah, of course. Especially if it's wrapped up nicely.
Exactly. We built composable read and write streams that the OCaml ecosystem, there's a couple of packages there that do something like that. But again, some of them have a very academic mindset, right? And I really want something that is built for the builders, for people like us that are building, apps, that are building SaaS services, that are building more libraries to build SaaS services, right? And that means we need to do something that's focused on readability, right? Not just performance and correctness, but also the developer experience, right? So the IO streams, Rio, we built a whole new kind of string for OCaml called byte string. Yeah, I know. Yeah, exactly. You're laughing. I was like, my God, are we really going to do this? And then we did it.
Like, there's one more thing we need.
Just one more thing. Just like one more library, bro. Like, I promise, just one more thing. And these are like the lower levels of the stack. And most of that is like nicely encapsulated by Riot. So when you build a Riot app, you just use Riot. That's like your standard library and your runtime. But on top of that, right, how are you going to build an actual app? It's hard because it's very low level. Like I give you TCP stream sockets, right? how are you going to build, your app with that? Who does that? Nobody does that, right? So we built Atacama, which is a connection pool, right? Heavily inspired by an Elixir connection pool called Thousand Island. We built Nomad, which is an HTTP and WebSocket server that runs on top of that is heavily inspired by Bandit from Elixir. We built Trail, which is a middleware framework, right? With routers and sort of pluggable middleware that is inspired by Elixir's plug. We built Sidewinder, which is like live views from Elixir, but for that stack. So, dude, if I show you, we have a massive tree of things, right? Starting from how do you compile this C code all the way up to, hey, I want to have a live component on the DOM on a browser updated via WebSockets, right? And we built a whole thing there. It's been like 5 months, and obviously this is not like 100% finished or production ready, but we have this goal in mind to make OCaml saas-ready, right? And I think this is really driving all of the work in the ecosystem, including some fundamental pieces like DBCaml by Emil, right? That are fundamental because every app needs a database, right? So if we don't have that, we're like, oh no, we cannot build real apps. So I'm really happy to have Emil on board as well, working with us.
So it's only been 5 months?
Yes.
I mean, that's all nothing.
Yeah, so just so you know, Fredrik, Leo, he's a shipper.
I like to.
You're shipping.
I was starting to suspect that.
But sometimes you also stream, Leo, and sometimes I just sit there and listen, like try to understand like how you think about stuff, because you are like, when I think about something, it's like this tiny, like this is like my mind, but you are already like 5 steps ahead, thinking about, okay, so because if we build it this way, eventually 5 steps ahead, we can also do this thing and turn it into this thing. And all of this stuff, and I think that's the mindset you have had for like the whole.
I think so. So one thing that really helps here is having a vision, right?
Yeah.
This is where I want to go. But the real trick here is that I've made so many bad technical decisions in my career, and have been at startups where some of those decisions have contributed to the startup eventually going out of money, right? And I'm like, I don't ever want to do that anymore. So I am so scared of making a decision now and the consequences it will have like months down the line, that I cannot not think about those things.
Yeah, I mean, it's really interesting with, like you say, mindset things like that, and how you build on previous experience, and that allows you to do something. But so how does it look like to your mind? Do you sit down and plan ahead a lot before, or is it more intuition and in the moment, like, yeah, I know these decisions could lead to this thing or this thing, so I'll try to push in one way or the other?
That's a good question, because I don't do a lot of like big planning. Only recently, like 2 days ago, we started writing a roadmap for Riot, right? Like trying to put together everything we've done. I think having worked in so many ecosystems has helped me see how people have built some of these things already. And I try not to waste time reinventing things, right? Like figuring out how to do something from scratch. If I know that Elixir has a great socket pool, I'm going to go there. I'm going to be like, how do you do that? I want to learn exactly how you did it. And then I'll translate that to the OCaml, right, that I know. So I save so much time, right? Whereas if I was essentially saying, I'm going to do this entirely from scratch, then I would have to, like, I would fuck up a lot of designs. But by building on top of the designs of other people, then we get a stack that can be made cohesive, right? And uses all the experience from all these communities, right? So it's not really just me pulling this together. I'm like, standing in the shoulders of many, many giants, right? Here. So I think that's a big part of why we've been able to move so fast.
Yeah, I mean, it's one of those things that shouldn't be strange, like looking at other people's good ideas and then using those.
I honestly, like, you want to be a 2x engineer? Learn from other people. Other people right there, they already have solved problems. You don't have to solve them again, right?
Yeah, exactly. And I mean, it's the same everywhere. I've been talking a few times to a guy called Johan Öbrink, who works really high up in management levels and works with teams and agile processes and all that kind of stuff. And he was also like that. Yeah, there's no secret to what I do. It's actually looking at people who did good things, and then I do the same thing instead of trying to reinvent the wheel.
Yes, exactly. I feel like we so much of the time we spend thinking, if I don't come up with it myself, I'm not a good programmer. I'm like,
No.
you'll be a better programmer if you learn from all the programmers, right?
Yeah,
And
exactly.
That's it.
Yeah, and I mean, as long as you make sure you understand what they did and like why
Exactly.
it's a good thing or not, you still need to have the understanding, but you don't need to reinvent the wheel yourself.
Exactly. Yeah.
So I was stuck with DBCaml for a while, and then I asked Leo for help. And the thing that you said, Leo, was like, hey, let's start, like, let's rethink this. Let's go into Elixir's Ecto and like study the connection pool. So we took like, I think it was like 2 or 3 hours or something like that, where we just like studied connection pool in Ecto and like understand like what is going on. And then we took the same idea, just put it into DBCaml. That's how the connection pool is built. Now there is some stuff that I need to fix within the pool because I know that there's like a bug, but I have written down the bug and I know about it, so I need to fix it. But like the initial vision, like it's just like Control C and Control V on Elixir Ecto's connection pool.
I wouldn't say Control C and Control V, but
No,
the
it's
design, the idea they
Yeah,
have,
yeah.
definitely.
Yeah, the connection pool is the same, but I also took like the Squealex idea of how you write queries and stuff.
So do you, when it comes to looking at others for inspiration and ideas, do you often go all the way down into the source code and implementations, or do you stay at a high level? Because I feel like sometimes I wonder if that's kind of a lost art, like if we should all be reading other people's code more, like understanding on that level, instead of just reading the README and this idea we implement,
Dude, like 100%. There's been streams where what we've done was essentially on stream read a library, right? And as we were building and understanding, like for most of the part, I already was familiar with some of these libraries, right? But understanding what are the design points that they have made, right? Like, okay, for example, right? Instead of keeping function calls on the same stack, maybe at some point they actually choose to bring that into a separate process. Why? Right? What are they trying to solve there? They're trying to isolate the failure here, for example. They have thought about this, and it doesn't mean it's a good idea that they did it that way, because, we all build bad designs, and
yes,
sometimes by accident they are still there, right? And but at least it helps us see and say, okay, they did this. Should we do the same thing? Yes or no, right? And then in that process, sketch what the library would look like for us in OCaml, starting from an idiomatic OCaml experience, right? Like the API or the types or whatever we need to consider, and then trying to go back from there, right, to the design, and from the design forwards to there, right? So we've done that live several times, and I feel like a lot of people sometimes get married to a language. And even though I exude OCaml these days, and everything I talk about is OCaml, I've read a lot of languages, and I would say I could read Go code even if I haven't written a lot of Go code pretty easily. We've actually built a whole project for writing TUI applications in OCaml called Minty, which was a port of a Go framework called Bubble Tea, right? And we looked at the code and we were like, how did they do this, right? Oh, this is how they do it. Perfect. Let's do the same thing. Done, right? Yeah. And we shipped it. And the Minty code is not large. It's like 300 lines of OCaml. That is the entire engine. It's like, nice. It is very, very tiny. And partly is because we've been able to look at the design that they already have and say, we don't want many of these things that are Go specific. We don't want many of these features. We just want to focus on the core, right? But if you're only focused on a single language and you mostly just read that language, you're missing out. You're really missing out on a ton of talented people in communities that use languages that maybe you don't like, right? Like, we talk about TypeScript and we say bad things about its type system, but it's crazy powerful. And some of the things people do with the type system there are like, hey, we could learn some of that, right?
Yeah. I mean, many people get a lot of stuff done in TypeScript, even though I sometimes get allergic reactions.
Exactly.
But
I wouldn't write Go
stuff
myself, but I'm happy to learn from them, right?
Yeah, exactly. I mean, I feel like there's such a problem within, I was about to say languages, but maybe it's communities. I mean, I'm thinking, I work mostly front end these days, so I'm thinking a lot about Node and the mess of packages we make all the time. Yeah. And I feel like that's one of those going in and trying to figure out what the problem is and what I actually need versus pulling in someone else's solution wholesale and hoping that it solves the problem for me.
Yeah.
It's like I hope I won't have to understand this problem if I pull in this package instead. But maybe I should go in and actually look what it's doing and seeing what part of this do I actually need. Could I replace this with an if statement? It's one.
Yeah, exactly. Yeah, 100%. There's like a whole organizational thing there, right? Around risk. It's like, do we own the risk of writing that code, or do we delegate that risk by having somebody else write it for us, like a package?
Yeah, but I also think it's I wonder if it's some kind of like incorrect or biased impression of like saving time or moving faster. Yeah. Like if I build this big, look at all the code they wrote. It must take me so long to write the same amount of code, so I'll just use theirs and add to my house of cards. but maybe my problem didn't actually take all that stuff if I had or took the time to understand it.
Yeah. I think that's also a good angle. Like the library will be a lot more complex than what you actually need, right? Because they have to handle other people building other things and edge cases and stuff like that. Yeah. And I'm not saying it's a bad idea to use libraries and you should write your own everything, right? Because, I don't know, sometimes it just doesn't make sense. But some other times, it's like, maybe just grab the things that you really need and use that. We have very, like, good licensing, I think, in most ecosystems. It's like MIT stuff.
Yeah, exactly.
So you want to grab that one file, grab it. Just slap the license there. You'll be safe, right?
Yeah, exactly.
And move on.
Yeah. You'll save yourself some package vulnerability problems later on as well.
Yeah.
in certain ecosystems.
Exactly.
Yeah, so 5 months so far. It's impressive. So how far have you come, or how far? I mean, it's an impossible question, of course, but like, how far do you feel you are along the road to where you imagine you want to be?
We are far, for sure.
Huh?
Like there's, like I've been building as fast as I can and as in a straight line to the goal as I can, right? But we're missing a couple of things at every layer, right? Like, for example, I know Gluon doesn't have support for Windows yet, and that's something I really want to have. Because I know devs that use Windows and they cannot use Riot right now because of that. The Riot itself, because of OCaml 5 and 5.1 having some issues with memory that are being fixed in OCaml 5.2, that it also has some issues with memory, right? Like if you run many processes and you like allocate big strings or big arrays, sometimes that memory doesn't get returned to the operating system, right?
Nasty.
Exactly. That's the face. It's like, ooh.
Yeah.
And so I've had some tests where I run a tiny program for like a couple of minutes and then I have like 30 gigabytes and they won't come back, right? I'm like, holy crap. And I have a whole machine there that is, exactly. It doesn't get clear. Yeah. Like the memory is reusable within OCaml, but it's like, what if the operating system needs it, right?
Oh, yeah. It's sort of the old Java thing.
Yeah, it's like there's no compaction up until 5.2. which is in alpha right now. So that's going to get better over time. So, some things that we need to do, some things that will happen at the OCaml level. I know that, for example, Nomad, our web server, is not entirely HTTP1 compliant yet, right? We're maybe like 80% compliant, a little less, 75. So there's work to be done there for handling different edge cases. That actually was, I think, a good example of looking at some other people's code. Because there is no test suite for checking if your web server, right, is like compliant with HTTP1. There's one for HTTP2 called H2Spec. There's one for WebSockets called Autobahn, right? And you can spin up your server and then you run it and it gives you a report. Like, this is what you're missing. So for HTTP1, what we did is that we cannibalized the test suite of the Bandit web server in Elixir. And we pointed that to our server, right? And then we are able to like look at those tests, which are mostly protocol only, right? And tell how far along we are. Cool. But if you're afraid of looking at all the languages, then that you would never consider that, right?
Yeah.
But if all of a sudden all the language is just another language, then bring it in and use it and so on.
Yeah.
And of course, like these are just examples. More recently, we rebuilt saas-ready, which is a serialization framework for OCaml, inspired by saas-ready from Rust. And we try to follow the design they have as closely as we could because it's very, very efficient. And we want that, right? But we're also missing things there. We're missing data formats, right? We only have JSON right now and S expressions, and someone's working on CSV, somebody's working on TOML at the moment. So I think maybe 6 months down the line, we will definitely have a more wide, right, like vertical slice of what you can do. Because right now you could build a couple of tiny toy apps that you can deploy somewhere, right? And we have done that already. And they like exercise the entire stack.
Yeah.
But it's not quite ready for you to build like your next SaaS with.
No.
However, maybe in the next six months, right, it will be more and more ready, and I'll see more people building things with that.
Yeah.
Hopefully that gives you some idea.
Yeah. Is there any part of that, the things missing right now that you feel are like the particularly tricky parts? Are there any big question marks or challenges?
From the current vertical slice, no, I think it's just work. Just sitting down and doing the work. Like,
filling stuff out.
Yeah, build it. Like, new data format for Certi, more tests for this thing.
Yeah, of course.
We would have to build at some point HTTP 2 and HTTP 3 support for Nomad. We'll see how that goes. I don't think that will be particularly hard. Just, sitting down and building against the spec.
Yeah, exactly.
But that's the good thing, because we are like the whole community, like with all of this project, is in a current state where people are able to come in and contribute if they want. There are issues that people can help with, and I know there are plenty of people like within this OCaml community that are like they want to contribute and help. So there is so much more effort into like the whole process of like building this whole thing. And that's the same good thing about this community as well, is like this extremely welcoming when it comes to like new people. They just want to learn. There's never been this like, don't feel pressure, don't feel like, just come in. We can help you on the path, like to get your goal, for you to come to your goals and so on. And you can have zero experience, you can have 30 years of programming. You're the same amount of welcome, whoever you are. So
that's awesome.
Yeah.
So I need to do a couple of shout outs here, because that community is not being built by itself. We have great community leaders there. People like Dylan Mulroy, for example, who also does a lot of streaming, and you should definitely bring to the podcast.
Cool.
We have Metami, who's also been a big pillar on making the community kind and understanding. We have people like Alice, Well-Typed Witch. Those are their usernames, right?
Awesome username.
That are always bringing like great content and sharing knowledge. Alice knows so much about type systems. It's just really inspiring. And every time we have a question, it's like, okay, here's a couple of like things you could read. Like sometimes it might be a computer science paper from the 80s in German, but the stuff is there. So it's amazing. Then of course, Privér and other people have been helping out in many different ways, right? But everybody has been streaming. And this is, I think, one big difference of how the prior communities in OCaml have been built. And is that this one has been mostly built around people that are streaming OCaml, right? And in every stream, we sort of like hop from stream to stream, helping each other build things and so on. So as Priv says, we've created quite a nice ecosystem, I think. I feel very happy that they're there. I enjoy jumping to the streams and having people also come to mine, right? And it's very wholesome.
Yeah.
And another person that I think is like extremely important is Sabine. Sabine is
Sabine! Oh my god!
Oh yeah, I was like, what? Man, Sabine. No, Sabine is working on OCaml. The OCaml, I think the OCaml community part, and Tardives doing a lot of stuff like building stuff for. She's currently building on a thing called the OCaml Playground and Cookbook.
Yes.
And Cookbook is pretty much like, imagine you're an experienced developer and you want to know how to build something. You can just go to this page and you can pretty much search for something, and there's like a recipe on like, okay, do this. You can just copy the code, even run it and so on. And that's like, I think that's really important. Another person I think that is also like really important for this whole OCaml community is TJ. It's called Teach the Reeves, if I'm not wrong. Teach_DV.
Yeah, Teach. I call him Teach. I don't know.
Same. It's like the Twitch name is Teach.
Yeah. That's what we go by.
Yeah, but he also like a big audience and like doing a lot of OCaml, talking a lot about OCaml. So there's a lot of people like doing heavy stuff, like just doing everything public. That's also really nice. Like,
yeah, everyone can see that things are going on.
Yeah,
exactly. Particularly, Sabine leads the OCaml.org team at Tarides as well. So we're coworkers. And the work they've been doing there is absolutely phenomenal. Like when I started learning OCaml, we had nothing like what we have today. And I like the tutorials we have there in that page are absolutely phenomenal. They are so oriented for people that are coming into the ecosystem, so they expect very little of you and they teach you a lot. And it's very hands-on as well. Absolutely fantastic job leading that team and making sure the community really like has a say in that.
Well, that's fantastic. I need to do some follow some links here. I feel like I have a lot of good stuff to discover. So yeah, do we have time to talk a little bit about DBCaml as well?
I can give you like a brief.
I would love to. Yeah, I want to hear.
But like the thing about DBCaml is that currently it's one package, and the reason why it's one package is because I didn't like when I released version 001, I didn't like actually know how to build like this. Like I didn't have the full vision, and I didn't know like to solve all the problems. So the currently DBCaml is like imagine this. You can focus as a developer. You focus on writing your queries, getting your types. You don't need to focus on like the whole thing with like security, like escaping strings and SSL stuff and all of this stuff. DBCaml handle that for you. It also handle like all of this pooling, all of this stuff. But what's nice about DBCaml is that I'm currently trying to break everything out into 3 libraries called, and the first thing is the pool party, and pool party is the pool.
It's a great name.
It's just a pool, and it allows you to like you can send. And the idea is, so how Ecto work is that you just give it something and it holds it. It doesn't know actually what it is holding. It just holds it, and then when you're asking for it, it give you it. It give you the thing rather than they taking something and executing and then returning back response. They just give you like an actual type, and that's the same idea of pool party. And so this means that we can use pool party to do more than just for databases. We can, I don't know, web scraping, I guess, could be a thing. It will isolate the processes. There's currently like a issue within pool party is that I need to make a good way to work with dynamic types. I haven't started on it, but Leo helped me, like give me some guidance. And then another issue is that I need to work on making it make it better when it comes to like booting up processes and stuff. And then it's DBCaml. And DBCaml, the idea of DBCaml is that it takes your params, your query, executes stuff using pool party, and give you back, actually just giving back you, at the moment, I think bytes. And the reason is that I want to make DBCaml to be used more than just one thing. So I had a conversation with Teach, and he said that, yeah, there is this nice library called Petrol. And Petrol is kind of thing, you specify your types and then you make queries using the types. Like you have, I think that if you are in the TypeScript or JavaScript community, what's it called? Like there is this big query builder.
Drizzle?
Yeah, maybe. Like you specify your type and you use the type to make queries. So it's a query builder. And by building DBCaml in a way that it takes the query and the params, it just execute stuff and return bytes back. It allows like us to build more stuff than just something that returns you, what can you say, that only takes a string as a argument or like a query. And then I have voy, and voy is not like the VOI, it's VO. What's it called, like in Sweden we call it says G.
We're gonna have to change the name, man.
Yeah,
no
I'm
one's
thinking
gonna
about
pronounce
doing
that right. It's gonna be like, oh yeah, I'm using vo or something like that.
I'm using not a scooter.
Exactly. Yes.
But okay, so let's say voch. That library, the idea is to be Skrillex but for OCaml in a way. So like the only thing you do is that you give it a query using a string, and then you give it params. In Rust, this is called the params is called binding. So you write the query, and then you bind params to specific prepare stuff, and then Skrillex execute the query, and then it takes the result from the database and map it to types. So, and that's the idea of Voch. To be like the Skrillex version kind of thing. But the nice thing is that by making dbcal the way that it returns just bytes, it could be really nice that we could build a lot more stuff than just this easy way, making queries. Because my vision, I don't like query builders. I think they're bloating queries. I want you to be able to see okay, and now I'm actually doing a select star from this table. You're able to do your own inner join, because I don't think that query builders in a way can handle for instance inner joins or joins in general in a good way. Sometimes a left join could be better than an inner join and so on. So I want you to be able to make that query yourself. But if there are someone that are the opposite of my vision, they can build using dbcal their vision. And that's the idea.
Yeah.
But I think the best part of the whole dbcal is actually pool party. The pool that allows you to send out a lot of items to a pool and reuse them when you want it.
Yeah, we'll link to the blog post about it, of course, as well. It's
yeah,
important.
There will be a couple of changes, and I will talk about it more. But I won't write about it on my own page. I actually bought a domain called dbk.ml, dbcaml.
Oh, nice.
So I will write it there. That's the idea.
Yeah,
it's great when you find that right domain.
Yeah, we bought a couple of domains on stream at some point. We found that some provider called Internet BS, they sold .ml domains, and we were like, oh my god, let's buy some. And we have dbcaml, we have Riot ML, we have saas-ready ML, and they were relatively cheap. And apparently we cannot buy many of them anymore. I don't know why. But they're there. We have them. So
awesome.
I also think that, if I'm not wrong, that .eml domain will be removed due to some thing in the States. Yeah, I think it was some mails been sending to the .ml domains or something like that.
I know that the US uses .mil for military.
Yeah. Oh yeah.
So that might have something to do. I don't think they will remove an entire top level domain, because God knows how many links are pointing to things like that, right? So most likely it will be no new domains get registered with that. So if you want your ML domain, buy now. It's
buy now.
So yeah, there will be a lot of stuff coming up, and we will talk about it public. We build everything in public, everyone that are contributing. As Leo said, we are building a lot on live on Twitch. We are talking it on social medias. I know there's some YouTube videos going on. Now we are on a podcast. We talk about it. So
yeah, there will be lots of links in the show notes.
yeah, definitely. At the very least, the Discord links need to be there.
Yeah. I like extensive show notes. So, I mean, throw links in the document. I'll put them in.
Excellent. Actually, I can give a big recommendation. Is that we have a Discord community called the Caravan, which is the Discord I was talking about earlier, but I didn't mention it. I didn't know if you like that kind of what's can you say ads and stuff. But the Caravan is it's open for anyone who want to learn not only functional programming, but a lot of talking is going on in the Caravan, and we can provide a link for that.
The Caravan is it started as this community from the streamers, right? Saying, hey folks, if you're watching our streams and they write OCaml, right? And you're enjoying it and want to keep chatting, you can join us here. And there's tons of channels. There's a lot of activity there. For the most part, we are talking about programming in general and just having fun, right? Having a very welcoming community. And we also do a couple of things we have a book club that happens every Sunday. and we're doing this book right now called Essentials of Compilation.
Ooh.
And different people sort of implement the book as they go, and we meet on Sundays to read and help each other implement parts. The book club is called Reading Rainbow, for those who know that reference. Yeah.
I don't think I do, but I like the name.
You maybe, I don't know if you are a Trekkie or not, just poking, but Jordi LaForge, Quinta Kunta, the guy who played Jordi LaForge in The Next Generation, they had a show called Reading Rainbow where they read books. And that's why the name was pitched, and I think it just stuck. Maybe the reference didn't hit a lot of people, but that's fine.
Yeah,
of course. It's our book club. It's
it sounds like a friendly reading corner thing. So it's perfect no matter if you get the reference.
Exactly, yeah. Gives us the right image out. Like, it's just a rainbow, it's like colors, and we're happy here, and we read.
Yeah, I imagine like a children's television program with a nice, animated rainbow and stuff like that. Sounds super friendly. Yeah, that's great. I guess it's... Unfortunately, I have to say, time to wrap up.
No worries, I understand.
Extremely interesting, and
we can make a version 2 later on where we have built more
exactly. Stuff. Yeah, we can do as many episodes as we like.
Exactly. Yeah.
Yeah.
Well, Frederick, thank you so much, and also thank you, Emil, for organizing this and the invite. Yeah. Super happy to spread the word of OCaml.
Yes.
And the gospel of the dunes, we call it. And I hope to see you and some of you listeners as well sometime in the caravan, either the Discord or some of our Twitch streams. You're more than welcome to swing by and say hi. And have a good time, a good day.
Yeah. Tusen tack för att du lyssnar på Kodsnack. Vill du stödja oss? Tipsa en bekant om podden eller lämna en recension i till exempel iTunes. Du kan också köpa prylar med Kodsnacktryck eller stödja oss med en kaffe på coffee.com. Alla länkar och alla avsnitt finns på kodsnack.se.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.
I don't think this is one meeting I will take on the walking pad. So I'm just going to sit down here.
Oh, we have a walking pad.
Yeah, it's been surprisingly useful, to be honest, especially for like long all hands and that sort of work. It's like,
yeah, that's pretty cool.
It can be a little boring sometimes.
Yes, so I hear. What brand is it?
I think it's called Walking Pad.
Oh,
there's a million of these things on Amazon these days. Mm-hmm. And my gut feeling is that they're actually the same thing with different brands on top, right? Because they all look the same, and they cost about the same as well.
Yeah, that's like the thing I was thinking about. I think I quickly Googled at some point. It's like, how do I know what to choose here?
Yeah, it took a while. I eventually had to make a bet, and it was like, all right, if I buy something that's too cheap, it's probably going to break, right?
Yeah,
like there's some that are like 100 euros. I'm like, that's going to break. If I don't want to buy something really expensive, like 1,000 euros, because I don't know if I'm going to like it, right?
Yeah.
So I found one that was like 430, 450 euros. And I was like, all right, that seems like a middle ground. I can still return it if I don't like it, right? But if I do, then I have something that most likely will last me a little bit, right?
Yeah. So how long had you had it?
4 weeks, I think, maybe 3 weeks. Yeah. I've been using it quite consistently. Like I have a streak of 15 days now of every day using it a little bit.
Oh, nice.
Yeah. Dude, sometimes you don't realize and you walk like 8 kilometers. And it's like, all right, that's really nice.
Yeah, that's really good. I used to be really good at standing up and working, but I've fallen out of that since the pandemic, I guess.
The body changes with time, doesn't it? Like knees do change, yeah.
Yeah. I can't blame that in my particular instance, but
I used to play rugby, and I don't have the knees I had back then anymore.
Rugby, that's a tough one for the knees, isn't it?
Yeah, exactly. Yeah. So when Privan says, I want to go play basketball at 10 p.m., I'm like, damn, you're young. It's like,
So true.
Even like Meta said it, Leo. He was like, "Wow, I'm not scheduling anything after 7 p.m."
yeah, same for me. 7 p.m. I don't eat. I drink water and I go to bed. That's it.
Yeah.